Hello, I have a challenge for you. In sitting, keep your eyes closed and do not perform the following actions. Only visualize them. Stand up, extend your right arm forwards and front, take 3 steps right, 5 steps back, 3 steps left, and 4 steps forwards, and sit down. Pause the video and see if you can recall these actions. It's quite challenging, isn't it? Now, I would like you to physically perform these actions with your eyes open. Stand up, extend your right arm forwards and front. Take 3 steps right, 5 steps backwards, 3 steps left, 4 steps forwards, and sit down. Pause the video and recall your actions. How did you go? Did you find it easier having performed the movements yourself? Research by Piaget, Brunner, Bowman and Tran supports the notion that movement and multi-sensory experiences using digital and non-digital technologies improves mathematical and geometric thinking, as it provides a bridge between concrete reference and abstract concepts. Therefore, it is vital that we provide our learners with experiences that will engage their sensory, motor, perceptual and neural systems. This approach will also support learners with intellectual disabilities, as it reduces the brain's cognitive load and frees up working memory and other cognitive processes to allow learners to think more deeply. Today, we will adopt this approach and apply it to one concept: grid maps. It's a vital skill that provides learners with a means to seeing and describing the world around them. It gives order to their surroundings and a way to go from home to school and from the classroom to the playground. It's a skill that's expected of our learners from as early as Year 3. Let's take a look. Grid maps on their own in a textbook will likely cause negative feelings. However, we can foster positive attitudes and cognitive growth by making the experience multi-sensory and meaningful. For example, we could create a large-scale map that relates to an environment learners are familiar with, like the playground or neighbourhood. Learners could then explore the map using their whole bodies and give directions to peers going from one point to another. With time, learners can move towards symbolic representations, like coding blue dots to move around smaller maps, and eventually progress to abstract representations, like using codes and grid systems virtually. To further progress learners towards abstract thinking, we should model and encourage formal and informal language, as demonstrated earlier. For learners who are non-verbal, AAC devices like PoloCode2Go and ALS boards can be used to support thinking. Finally, peer-to-peer learning, collaboration and ongoing formative assessment that builds towards summative assessment, like dialogic talk, observation and constructive feedback of learners' maps, gestures and verbalizations, can be used to foster their conceptual understanding of grid maps. Thank you.